Hello, welcome to STEM with Mr. Duda, and in this series I'm going to be talking about sensors and exactly how they work and the information that they are sending from the sensor to your device. And in this case I'll be showing you through an Arduino. So stick around. All right, so today we're going to be talking about a light-dependent resistor. Now we use this on one of the Arduino projects. I think it was the RGB light where we shined a light and we had a light bulb lighting up the same color, I believe. I think so. Maybe not. I don't know. Whatever. Either way, this wouldn't do the same color, so I'm incorrect on that. But we did do a project on it. This is a light-dependent resistor right here, and what it does on the one part right here, it's able to sort of sense light. So depending on how much light is shining on it, it resists electricity more or less. I don't know which one it is, if it resists more, the more light there is, or if it resists less, the less light. But I'd imagine the more excited it is with light, the less resistant it is, but I'm not 100% sure. There are 3 pins on this one. There's a ground, a voltage in, 3.3 or 5, or anywhere in between, and an output. And so I have it set up, and let me show you how I have it set up on my camera, and maybe I can transition this to a full screen. Let me do that. All right, so I have my Arduino. I don't have my wires the correct colors. I just couldn't find my red and blacks, but I've got positive and negative running to the photoresistor, and I'm going to shine a light on the photoresistor while I show you what it looks like in the serial monitor. But first, let me show you the code. So let me get it nice and big. Here's the code for you. And if we're looking at the code, and let me get that code on my screen. If we look at the code, I'm saying, hey, there's this sensor pin. It's an analog input. It's not going to be just a 0 or 1 or a pulse width modulation. It's going to be a value 0 to 1024, I think it is. I'm saying I did not hook up an LED, so we don't need this, and I actually erased it from the rest of my code so we can get rid of that. And we are just giving a variable called sensor value. We don't even have to say equal to 0, but might as well give it a placeholder for the time being. We say this isn't even required. We say serial begin 9600. Sensor value equals the analog read on analog pin 0, and then it's going to print that value. So when I put that out into, if I hit tools up here, I know you can't see it, but then I hit serial monitor, and I will change this to show you the serial monitor. It gives a bunch of values, and you'll see it's sort of jumping between 100 and right around 170. Now, as I change this, if I get it closer to my light, you'll see the number will change. I'm going to turn the flashlight on my phone, and watch when I shine it on there. You'll see the number gets much, much lower. So maybe resistance goes up. Now as I move my light away, see I have a light on. As I move my light away, it gets higher. If I turn off lights, let me turn off this light in front of me. If I cover it up, you'll see it gets a lot higher. And so depending on the value, I could say, hey, when there's this much light in my room or this much light in my room, I want to do something. Maybe turn on my lights inside or play certain music, whatever. You could take that, and I'll go back really quickly. You could take the value from this sensor value and say when sensor value is between these values, do something. So that is the photoresistor module. Hopefully that was enlightening for you. Hopefully it helped you to better understand it a little bit. And I hope you have a wonderful day. By the way, feel free to subscribe if you'd like.